Alright, good afternoon everyone. Just wanted to briefly lecture on Chapter 8, which is about principles of security models, design, and capabilities. So specifically what we'll be covering today, secure design principles, techniques to ensure the CIA Triad is met, fundamentals of security models, as well as security models themselves. So a couple principles to go over. I'll go through these. We have subject and object. So the subject is who's wanting to access something, and the object is what they're wanting to access. So in a traditional sense, you may think of this as being the subject as the person, and the object being the system. But many times that's not the case, because there could very well be a scenario in which you have a subject that is a system, and an object that is another system. Okay, I think that's a pretty common occurrence, actually. So really just think about it as a who and the what. Okay. And of course you also have the idea of closed and open systems, and generally speaking this refers to the source code of the systems. If something is closed source, it means the source code cannot be reviewed or accessed. If it's open source, generally speaking that means that it is freely available source code. Does not mean that the price is free. You can certainly have paid closed source, you can have free closed source, and you can have, of course, paid open source and paid closed source. So generally speaking, with the open source that would be paid, okay, that's probably going to be referring to a long-term support contract, or some sort of support contract, I should say. It doesn't have to be long-term. So if you take Red Hat Enterprise Linux and you compare it to Fedora, it's basically, there's a lot of shared code. I'm not going to say 100%, but they're both open source products. One of them you pay for, one of them you don't. Okay, so with Red Hat Enterprise Linux, you pay for it, but you're really paying for the support. Okay, something like CentOS. I believe there's a newer name for it. I think CentOS is no longer. Could be wrong about that, but it's literally taking the code from the source code from Red Hat Enterprise Linux, and it's basically compiling it and providing the same exact stuff for free. Okay, that's totally legal. All right, nothing illegal about that actually, because the licensing agreement allows for it. All right, default settings. That's something you probably want to avoid on most things. So default settings, just referring to if you take a piece of hardware or software out of the box, and I use box kind of figuratively here, what is it going to be configured to do? Okay, most of the time it's going to be using insecure passwords. Maybe you have admin accounts that aren't properly used, whatever the case is. Generally speaking, you want to customize things. Okay, it's going to be a lot more secure. You want to make sure that you're documenting everything. We'll cover all that. All right, then you have the idea of failing securely. Okay, so if something is configured to fail securely, it means that upon some sort of failing condition, could be a physical condition like I have on the example of the magnetic door lock. Okay, if it fails securely, it's going to default to a locked position. Okay, if it can't communicate with a server, if there's a power outage, anything like that, it's going to default to being locked. Also an application. Let's say that it receives some sort of error. Okay, if it fails securely, what's going to happen is it's not going to open up the entire database to be accessed. It's going to keep it secured, and it's not going to allow any access. So that's obviously what we're referring to with fail securely. Of course, we have the idea of keeping it simple. That's just saying don't have your measures be overly complicated for anything, really. Okay, you have the idea of zero trust. Zero trust says we're not going to inherently trust anything on a network. We're not going to trust any device. We're not even going to trust any person. Okay, and that has a lot of advantages from an organizational perspective, but obviously some disadvantages. So you have to balance that sort of thing. Can you trust your chief information security officer? You'd hope so. Okay, if you can't trust your chief information security officer, can you trust anyone in your organization? Maybe not. All right, privacy by design, as the name would imply. You're taking whatever application or system or hardware, whatever you're using, and you're building in at the design phase the idea that user data is private. And specifically, I would add to this that your not just believing that it's private, that you're following a privacy policy, okay? Because if you don't follow your privacy policy, you open your company and possibly even yourself up to legal action, okay? And you'd never want to open up your company, or yourself especially, to any sort of legal lawsuit, anything like that. All right. And then lastly, of course, we have trust but verify. As the name would imply there, you're trusting something, but you're verifying it. Okay, so that contrasts with zero trust. All right, kind of distinct policies there. All right, so a couple different techniques to ensure you're having the CIA Triad goals met. The first is going to be confinement. So if you have an application, what confinement is doing is it's running it in a sandbox environment. So that application can only access whatever is intended to be accessed within the application. So a great example of this is like I wouldn't say any, but the big two mobile operating systems that we have. We have iOS, and of course we have Android. You could argue whether or not Android's truly an operating system. I don't feel like having that debate tonight. Let's have it next week sometime. But the idea is, both of those operating systems, they have their applications sandboxed. And arguably a lot of macOS applications run this way as well. Less so on the Windows side. Definitely less so on the Linux side. But it all depends, because you start getting into stuff like some of the different apps on. I mean, you could argue a lot of this, okay? But the idea is that with confinement, it can only access what it's intended to access, okay? And then bounds is where you specify hardware resources, okay? So you give an application, say, 2 gigabytes of memory, okay? That's what it can access. That's its bounds. All right, and then isolation is similar to limiting to hardware access, but it doesn't limit it to prevent resource usage. It limits it to prevent, some sort of snooping and that sort of stuff on like memory contents and that sort of thing. So generally speaking, isolation is going to happen at the OS level. It can technically happen at other levels as well. So let's say that you are running virtual machines. Okay, let's say you have some sort of VMware license on a server. All right, you can certainly configure the isolation to happen also at the virtual level, and that's something that will take place. Okay, but for the most part, if you think about a traditional install on bare metal, obviously the isolation is most likely going to be occurring on that particular operating system level. Okay, access controls, I think we've talked about those a good bit. It's basically just the whole idea of identifying, then confirming, and then authenticating, and then providing access. Okay, really straightforward there with access controls. We've gone over that. Trust and assurance, pretty related as well. The idea with trust and assurance is that you have your different applications, and some applications are trusted, some aren't. Okay, and think about like the certificate authority we talked about. I think chapter 7. Okay, so certificate authority, that is your trust and assurance for websites. That is how you verify web certificates, SSL or TLS. Okay, think about if you have a certificate, maybe like a PEEP or maybe even just an EAP, so EAP or PEAP, running on a wireless network. Okay, that's how you can verify an SSID is who you think it is, because let's face it, there's zero things from stopping you from setting up an edge of your own SSID and broadcasting it on pretty much any campus. Okay? Nothing stops you from doing that. What stops devices from connecting to that would be if the network were using a certificate. Like I say, either protected EAP or just regular EAP. All right, pretty straightforward. We covered that last semester in networking. All right, so trusted computer base. Okay, this is where we're really looking at computing as a whole within the organization, and whatever the IT department establishes, that is our trusted computer base. And around that, we establish a security perimeter. So we have internal network, that's inside the perimeter. We have external network, maybe in a DMZ, maybe on, I don't know, just an outside network, okay? That's outside the perimeter. I think that's pretty straightforward. Information flow model, that's looking at how the information is going to flow throughout a system as well as throughout an organization. So non-interference model is kind of the opposite of that. It's looking at where the information doesn't flow, basically. And then finally, the access control matrix is there to have a list of user groups, most likely. You can technically do it with users. The book uses an example of doing it with users. But let's face it, even an organization like Fort Lewis, where you just have, I don't know, around 500 employees or so, I'm just guessing, that's going to get pretty messy pretty quickly. Okay, you got 500 people. Most organizations are going to do it with user groups. They're going to say these groups can access these resources. And there could be some exceptions here and there, and that's something that you would address. Okay, so you're not going to be too concerned with the exceptions. Okay, but the idea is that you have a basic matrix. So matrix, of course, being that you have rows and columns, and it's just a pretty standard little thing. I think you've seen plenty of matrices in your day. All right. So some different security capabilities. Memory protection. That's going to be something that it's going to be a lot more of an issue on server devices, particularly cloud-hosted devices where you're sharing bare metal. Okay, so while you may have access to a virtual machine, there may be other devices on the same memory stick as you. You don't know how many devices are on there, or how many virtual machines rather are on the physical hardware. Okay, and of course another term for physical hardware that I use is bare metal. Okay, it's a term that you'll hear a lot when you get a job. All right, it's just basically saying, if we have a physical server, we install something directly on it. We installed it on bare metal. All right. So memory protection, of course, is the encryption of memory contents. The idea is that it's going to prevent any application from, I don't want to use the term listening in on the memory because that doesn't make sense. Basically, taking the memory contents. Okay, because it can certainly be done, and it has been done many times. So, if you have something particularly sensitive, it's best practice to either not host it in a cloud, or if you must host it on a cloud for whatever reason, negotiate a private cloud contract. Now, the thing I'll caution you on is compare prices very carefully with private cloud versus self-hosting. Okay, because in a lot of cases, private cloud will be more expensive. Okay, because you're not getting that benefit of scalability because it's like one of you has to have the bare metal. Okay, it's either your cloud provider has to dedicate an entire bare metal assembly to you, or you have to dedicate the entire bare. So you're not saving a lot of money in a lot of cases. Now, if you're a smaller company, you could still be saving money by not having to have a data center. So, give you guys a quick little story. The lab, we have the server rack in there. To convert that room to a data center, we received quotes for over 30 grand, and that's for very basic things that I would have quoted much lower than that, as just kind of ballparking. So one of the things is HVAC system is going to be about 25 grand. Okay, and that's pretty costly. Ripping the carpet out and replacing it with what's already there, which is just going to be concrete. Maybe doing a light sanding to get rid of any adhesive, anything like that. Okay, that's another 2 grand. Okay, and realistically, you're looking at that room, you're thinking that's a 200 square foot room. How does it cost 2 grand to remove carpet? Well, you're asking the wrong person. Okay, but also getting a 30 amp service line in there. Okay, so to run, the PDU and that sort of stuff, that's going to be another 5 grand right there. So over 30 grand we were quoted. Okay, and that's very costly. Like I said, it's a very small server room, just 200 square feet. Not a crazy amount of cooling, not a crazy amount of any of that other stuff. But that just shows you that while the cost of the hardware may be the same, and they're probably going to upcharge it a little bit, having a server room is not cheap. And not to mention, you're dedicating that physical space to that one particular purpose. So for a smaller company, it still may make sense to go to private cloud. I would say that in a lot of cases for larger companies, especially if you have multiple offices that you can put it in, I would say it almost never makes sense to use a private cloud. Just locally host the stuff that's sensitive. That's my opinion. Okay, there's a lot of different opinions. All right, I don't mean to go off on a tangent here, but I think it's pretty ridiculous that we're quoted $30,000 for an HVAC system. Okay, because if you think about it, you can go get yourself a completely like a mini split or even a packaged terminal air conditioner. That shouldn't be more than $5,000 in my opinion. The hardware is very inexpensive. I guess the difficult part would be running the lines for the refrigerant. But, in my opinion, that's a ridiculous estimate. I was not too happy to hear that personally, okay? Other people have different opinions, okay? I'm just telling you, stuff's not cheap when it comes to having a local data center. That's the whole purpose of that tangent. Alright, virtualization. Okay, so virtualization obviously is when you have a piece of bare metal and instead of installing stuff directly onto it, you install, a lot of times you may install an operating system directly onto it and have the operating system run virtual machines on the operating system, so you have a host machine. That can certainly take place, but in a server setting, more likely using some sort of solution, maybe something like VMware, maybe something like, oh gosh, I can't think of it right now. There's an open source thing as well. It'll probably come to me eventually. But I think for the next lab, I think I'm going to have it be a virtualization lab. So you're going to install a couple different VMs. Hope you have the disk space. The good news is you can work together. And I'll send out details about that later as well. No need to rush into doing anything. But yeah, I think it'll be very beneficial for you all to use Windows Server. I think that'll be a beneficial thing, so I'll probably have that be one of, if not, it'll be part of it, if not the whole thing. We'll see. Like I said, I don't want to overwhelm anyone with homework or anything like that, so I'm not going to do too much at once. Alright, TPM, Trusted Platform Module. That's going to be used to encrypt and decrypt efficiently. Okay, so the idea is that we're taking data and putting it through a TPM, and it's going to basically offload a lot of that from the CPU onto a dedicated piece of hardware, which is obviously more efficient. Because CPU, especially on an x86 architecture, it's pretty basic knowledge that it's a complex instruction set. Okay, so that has inherent inefficiencies with anything you do with it. However, it allows you to do a lot of different things with it. Okay, that contrasts with the idea of like a reduced instruction set. Okay, with reduced instruction set, ceteris paribus, it's going to have more efficient for the task it's designed for, but it's just not designed for every task. All right, that's a very vast simplification, but I just want to kind of go off on that a little bit. So interfaces, that's pretty obvious. You're interfacing with the equipment. Fault tolerance. So with fault tolerance, the idea is that if you receive an error, how do you handle it? Okay, and we talked about that with having fail-safes and that sort of stuff in place. But the general principle that you want to look for here is that you're following the best practices. Okay, so the best practices for fault tolerance are to account for them, to collect them, and basically, you're going to have to do whatever makes sense with it. All right, encryption, decryption, we just talked about that for 2 chapters. The gist there is encrypt everything you can, okay? And, that's basically what you need to know about encryption. Okay, if you can encrypt it, you should. If you cannot, you should look into why you cannot. Because in general, try to find a way around that. Like I said, if you're using something, encrypt the memory contents. If you are, using a website, encrypt your connection. You have lots of different ways to do that. Okay, so obviously you can use HTTPS, you can use TLS, SSL, those sorts of things on port 443. Obviously you can also use VPNs. Okay, so you can use IPsec to encrypt the entire thing and form a tunnel. Okay, we talked about that last semester. So some other general tips for security. All right, you have the idea of documentation. You should document everything related to IT. You should document what hardware you have. You should document why you have the hardware, where the hardware is, who has access to the hardware. What sort of firmware updates do you do? I mean, anything to do with the hardware. That's something that should be documented. Anything to do with software, which versions you have access to, known vulnerabilities with each version. Document stuff about the image. How's it configured? Why is it configured that way? Who's responsible for what? Everything in IT should be documented. All right. I think that's a very important concept, and that's probably one of the most important concepts from this class. Is to just document everything possible. All right. So for the lab, Paul and I share documentation. It's a couple pages long, and it goes through, an inventory list. We go through and we describe the furniture in the room. We describe the hardware that we have. We give the specifications for it, the models. We certainly go through and I describe the different switches and route. I mean, everything that we have is documented. Okay, how it's maintained, I document that. All right, I go through and I do that, and Paul has access to that as well. All right, and I'm not saying it's model documentation, but it's ample to have someone come in, read the documentation, understand what's going on. Okay. Role-based access control and the principle of least privilege. Again, you have different roles. Put them in a matrix if you want. Assign what they can access based on that role. All right, then you have, of course, centralization. And this is a very important concept as well. So a lot of organizations, particularly government and higher ed, are kind of notorious for having many IT departments. All right. I don't think the Fort does this, at least not to my knowledge, but bigger universities and other universities, they certainly have different IT departments. And that gets to be a disaster, okay? Because you have one sort of generalist who runs a whole college's IT, and they may be responsible for building images and stuff, and you don't know what they're doing to those images. There's not a lot of communication between those functional units, because they're not the same functional unit. All right, functional unit, of course, being another name for department. So, having that not be centralized, you don't know what the department is doing, even though it's not one department, but you get the idea. You don't know what's on the PCs. That's a disaster, okay? Where you have centralization, you can have specialization. Specialization being, you have some people responsible for building an image. You have some people responsible for deploying the image. You have some people responsible for help desk support. You have some people responsible for AV systems. That's a lot more efficient, and that also is going to provide a lot of advantages for just having things be more secure. You have a dedicated security team. They're responsible for reviewing everything related to technology, sometimes even everything related to the organization as a whole, although that's probably a lot less common. All right. So things like updates, that should be done centrally. If you have an organization, you should have dedicated servers that provide updates, not just for Windows or Mac OS or whatever platform you're using, but for any software that you have. Okay, that should be hosted locally in most cases. And the good news is that can be done mostly automatically. All right, you don't have to do a whole lot of configuration of that sort of stuff. Installations. What software do you allow? How do you allow software to be installed? If you're talking about best practices for security, I would say that it's probably in most large companies' interest to not allow end users to install software. Instead, maybe have like a locally hosted, and I'm not saying like an app store like the Apple App Store, I'm saying have a local application store that the organization maintains. It can push out updates. It can do approved software installation. That's going to have a lot of it, not just for security. So you can't have some user, I almost said something else there. You can't have some user load ransomware on the whole network, okay? Because they can't load ransomware at all because they can't install anything, all right? That's a pretty important point, all right? So instead, they can install approved applications from the localized app store. And that also helps with licensing. You can't have some person go off and install some free to use for home use software that is not at all free to use for commercial. Right? You don't have that problem when you have centralized installation. Purchasing. Supply chains are important. Okay? For personal use, yeah, I purchase stuff on eBay all the time. All right? For business use, I would never purchase hardware from eBay. All right? You don't know where it's been. You don't know what the history of it is. You don't know if there's any sort of stuff done to modify, say, UEFI. You don't know that. Now, having said that, you could argue, well, what about companies that have had issues where they modified the UEFI in a negative way? So, for instance, Lenovo, 3 separate times they've installed malware on ThinkPads. I think only one of them were actually new devices, but still, refurbished didn't exactly chop deliver, okay? So if I were a purchasing manager, I obviously love ThinkPads, okay? I have several that I own personally. The entire lab is ThinkPads, although that wasn't really by my choice at all, it was just whatever was donated. I love ThinkPads, I think they're great hardware. But knowing that they've had 3 separate instances where Lenovo has installed malware on them, in one case, at least one case, it was at the UEFI level. You could wipe and reinstall the non-volatile storage, and it would still be there. Okay? Would I recommend that my company purchase Lenovo? Absolutely not. Okay? I'm just being blunt. I hope no one's offended by that. I'm not trying to call out any companies. Just using Lenovo as an example there. Okay? I would not trust that company. And I would hope that none of you would trust a company that has a history of doing that. Again, one time on refurbished devices, maybe you'd let it slide. But 3 times, one time on new device, that's insane. So I would absolutely not want that company to be on an approved purchase list. Another key reason why you would have purchasing be centralized is obviously, you want to have as few different devices as possible. It makes getting spare parts much easier, makes working on stuff much easier. Just makes IT management so much easier. You don't have to worry about 50 trillion different drivers, Now, it's not always easy to do, okay? And there's a lot of cost associated with that. So, maybe you can't obtain, whatever model that you had before. Maybe that's literally not available anymore. Well, in that case, what are you going to do? You're going to purchase a newer model that has different stuff. There's going to be inherent fragmentation. You can't avoid it, okay? Avoid it as much as possible, though. Centralized purchasing, you don't have as many problems. All right? And then, of course, also, make sure you have good policies in education. Again, I think that's pretty self-explanatory. Have good policies in place that dictate what's acceptable to do on hardware, what's not acceptable. Educate people on, common scams, that sort of thing. Just have good measures in place to, have the best experience possible. So if you do these basic things, you'll be in a pretty good spot. Obviously there's a lot to talk about with policies, network policies, computer policies, hardware policies, software policies, so many different things. But just have good policies, have good education. Specialize in different tasks. Use role-based access control. Centralize whatever you possibly can, because it's going to greatly reduce your cost. It's going to provide a better experience overall, and it's going to be more secure. So, those are the basic things we're going to cover today. Just kind of wrap things up. We talked about secure design principles, talked about techniques to ensure the CIA Triad, talked about fundamentals of security models, as well as security models themselves. So hopefully we'll be back in the classroom on sometime soon. We will see the specifics on that. Like I said, I do hope to be back on campus at least Monday. We'll see. I'm not going to promise anything, but hopefully I will be back on Monday. So with that, thanks for watching. I will see you all sometime next week. So have a good one.